everything you need to know about Airbus's zero-emission plane. Many automotive manufacturing companies like Tesla revolutionized the automotive industry to become more environmentally friendly by introducing electric vehicles. Now another company is eyeing to make a debut in environmental-friendly productions. But this company is not an automotive manufacturing company, but an aviation company, Airbus. Airbus has introduced 3 ideas of climate-friendly zero-emission aircraft that will use hydrogen as its main fuel source. 3 concepts, called ZEROe, could be implemented in 2035. In this video, we will tell you about everything you need to know about Airbus's zero-emission plane. Just before we start, make sure you are subscribed to our channel. Also press the bell icon to get a notification whenever we upload something new. Now let's start. The Airbus Initiative is an attempt to reduce the impact of commercial airlines on the global climate. These 3 aerospace aircraft designs aim to omit the use of carbon in the aviation industry and can provide a solution to meet the industry's climate-neutral objectives. According to the International Air Transport Association, the aviation industry accounts for 2 to 3% of global carbon emissions. In 2009, the industry set 3 goals to address climate change: 1.5% fuel efficiency per year from 2009 to 2020, limits on net carbon dioxide emissions, and a reduction in total carbon dioxide emissions by 50% by the year 2050. Why hydrogen? Airbus planned to market a zero-emission passenger aircraft by 2035 means it needs to start planning a technological course by 2025. In fact, it may need to schedule several courses. That is because there is no single technology that can meet the energy needs to propel all types of aircraft, from flying taxis to short, medium, and long aircraft. While recently focusing more on small-scale electric aircraft, Airbus is now looking to hydrogen as a potential solution to its CO2 problems. Airbus has started talking about hydrogen with aviation companies, energy companies at airports, because this kind of change needs to be integrated across and within the aviation industry to make it happen. Hydrogen has long been regarded as a viable fuel by researchers, but so far it has had little practical support. Maybe now, with batteries not quite up to par, hydrogen's time has come. Why 3 concepts? Here, Airbus is not talking about new aircraft programs, but about ideas to express their ambition and to show what this future aircraft can look like. They are working on 3 different zero-hydrogen-powered planes. The turbofan design powered by hydrogen, rather than jet fuel, through the combustion of hydrogen with 2,000+ nautical miles range will operate intercontinentally. A turboprop design having a capacity of up to 100 will have a turboprop engine instead of a turbofan and will also be powered by hydrogen combustion on gas turbine engines. It will have a target range of 1,000+ nautical miles, making it is an ideal choice for short trips. The blended wing body, with a capacity of about 200 passengers due to its extensive cabin arrangement, opens up many options for storing and distributing hydrogen. Airbus is currently pursuing the idea of the cryogenic tanks under the wings. Passenger capacity and nautical miles range will be the same as the single-aisle concept. All 3 Zero aircraft are exciting ideas and offer many future air travel benefits. Over the next few years, Airbus plans to refine all 3 concepts to make sure they have developed enough technology to fulfill their zero-emission project. How will they work? There are 2 main ways hydrogen fuel can be used to power a plane. Combustion. This is very similar to how jet fuel is currently used and how the standard car engine works. Converted jet engines can use hydrogen as a fuel source, fueling the engine as it is now, but in a much cleaner way, used to power a fuel cell. This is a different concept, in which hydrogen is used to create electricity inside a fuel cell to power the aircraft. This occurs by combining hydrogen and oxygen. The reaction produces electricity, heat, and water as byproducts. Fuel cells have been around for a long time and already have many applications. Hydrogen-powered buses and other vehicles are common sightings. Many small aircraft built to date have used fuel cell technology. In large aircraft, however, direct combustion may be used, at least initially. However, an aircraft will need to have an onboard hydrogen supply, just as airplanes today require jet fuel. This requires storage in compressed tanks, which is much more complicated than storing conventional jet fuel. It cannot be stored on the wings, and instead, tanks are needed inside the fuselage. With smaller and low-range planes built so far, this is not a major problem. But with larger aircraft, we may see redesigns to accommodate this. The fuselage may need to be long, with separate chambers and fuel storage. Airbus also considered blended wing design as part of its ZEROe project, which could allow for more hydrogen storage options. Safety targets. Safety is a major challenge with hydrogen. It is imperative to achieve the same or better safety goals than the airline companies have achieved in existing aircraft. All solutions require working with engine manufacturers, but the relationship was already extended beyond the aviation industry, and Airbus was working with a car manufacturer. The United States in recent months has been following the European course, meaning that two major players are in the race, indicating that others will follow, especially India. Airbus asserted that they were working with all major engine manufacturers, as without them, this project would not be possible. Limitations. Limitations start with physics and chemistry. Hydrogen is much more energy by mass than jet fuel, but it is much lower in volume. This decrease is because it is a gas at atmospheric pressure and normal temperature. The gas needs to be compressed or turned into a liquid by cooling it in extremely low temperatures, down to -250 degrees Celsius, if it is to be stored in sufficient quantity. Pressurized gas or liquid storage tanks are heavy and much more complex. And there are other challenges as well. The density of liquid hydrogen is about a quarter of that of jet fuel. This means that with the same amount of energy, it needs a storage tank 4 times the size. As a result, the planes may need to carry fewer passengers to make space for the tanks, or they will be much larger. The first option, which works on Airbus' first 2 concept planes, could mean a reduction in ticket revenue, other things being equal. The second option, combined with the third Airbus concept, requires a larger airframe, which means more drag. In addition, new infrastructure will need to be put in place to transport and store hydrogen at airports. In addition, there is the question of whether hydrogen can be produced at a competitive price without itself having a large carbon footprint. Most of the hydrogen used in the industry today is produced using fossil fuel methane, releasing carbon dioxide as a waste product. Hydrogen can be produced from water by a process called electrolysis, which is driven by renewable energy. But this process is currently expensive and requires a large amount of energy. About 1% of hydrogen is produced in this way at present. In the meantime, one thing remains certain. Hydrogen and e-fuels may continue to be more expensive than conventional fuel for many decades to come, reducing their contribution to the greening the aviation industry, unless other aviation costs become cheaper. That's all for this video. We hope you liked the video. If yes, then give us a like and stay tuned to our channel for more tech-related videos. Bye!